Yeah, thank you for showing up, coming to my sessions. Maybe it's a little bit odd on a developer conference to talk about low-code, and Konrad already said kind has a stigma with developers. This is why code is bad, why low code, why making code less code. And you know, there's out there the term of no code even, so no code at all. And why to talk about this to developers? That might be a bit odd. On the other side, it's first of all, it's a big marketing hype. So it's not really clear what is behind this actually. But it's also a big trend and a lot of different forces and developments going into the direction, at the end, making developers more efficient, making building apps easier, faster, and not getting developers out of the job. So that is one of the main, hopefully, messages you will get at the end of the talk. A few words to myself. My name is Christoph Windheuser from Germany. Yeah, a long time in the industry. I worked for SAP. I worked for Capgemini as a technical consultant. I worked for ThoughtWorks for 4 years. And then I moved to a company where I'm actually working. The company is called OutSystems. And OutSystems is a provider of one of the low-code platforms for app development. And we will look a little bit into that. As I said, I think this is a good side from one of my former colleagues from OutSystems, Mike Mason, the global head of technology, who said there's the stigma that code is bad if you hear about low code. So in my talk, let's look a little bit behind the scenes. So we want to check why is this coming up and why this is an important trend. Probably also will affecting you in some way in your role as a developer in the future. And then what is it actually? It's a huge field, and what different kinds of low code, no code are out there, and why do they claiming to make developers more efficient? So what is the secret sauce? What is behind this? Then looking a little bit, if you are considering to use low-code for your work or in your company, there are a couple of things to consider. You cannot use it just for everything, even if marketing or sales is claiming that, right? So for what it is good, where you should be careful. Let's look a little bit into that. And then I think super interesting, what is the future? Yeah, how things are developed. Dave Farley has talked about developing in 100 years, right? Will this be in low code or in the robots are doing this? Where we are going in this field. At the end, I just give a brief summary. So that's the whole talk. So let's dive into why low code. Developing, writing software, you all know, is still a very manual process. Dave Farley in his talk said even that is kind of a craftsmanship, right? I mean, we are talking a lot about engineering. It's not purely craftsmanship, but like this guy building a violin, you need a lot of skills. You probably have studied it, right? Not everybody is able to do this. So you need experience and all the knowledge. That's what you hear in conference like GOTO. This is great for you as a developer. You have these skills, and there's a high demand for you in the market. On the other side, there's a huge demand in the future already now to build apps, to build software. You know, we are moving in the direction of digital transformation. Everything is becoming digital. You know this in your daily life, and probably you are upset if things are not yet digital, if you have to go to the town hall for silly things, right? And you said, hey, why can I do this online? And the answer is, there is no software yet. So we have to the world has to build millions and millions of software and code and applications in the future. You see here a study from IDC saying that 500 million apps have to be built in the next 3 years. And that's a study from 2019, so we are already there. And probably this is still augmenting. On the other side, if you see how many developers we have worldwide, that's another good question. So we have 50 million Stack Overflow visitors each month. Not all of them are developers, obviously. They are hobbyists, they are whoever is searching for a term. We have 40 million GitHub users, right? Not all of these 30 million are professional developers. Again, students, hobbyists, and so on. There is investigations by the Evans Data Corporation regularly. They say that's maybe a conservative guess, but 24 million about this. Maybe it's a bit more now. So say maybe we have 30 million developers worldwide, right? Actually, you are some of them. And you know how high the demand is. And that is exactly the reason here. If you do a little math, you see that each developer has to build 5 to 6 apps per year. right? And every single developer, including specification, testing, deployment, everything what belongs to building and maintaining an app. And as you know, you usually work in teams. That's even worse. So as a team, maybe you have to build 50 apps or 10, 20 apps per year, right? And you see this is really hard to achieve. And it's great for you, so there's a high demand for developers. On the other side, it's bad for the global economy and for the growth, because we need this software for maintaining the economic growth worldwide. So we would probably end in a crisis and cannot continue this digital transformation if we lack the developers. So the question is, what can we do about this? And basically, there are two things. First of all, make developers more efficient so that they can build more in the same time. On the other side, or additionally to this, enable more people to develop. These are the two things you can do. And that's exactly what low-code is and no-code is trying to addressing. Low-code is you still coding, but you make coding really easy and as efficient as possible. And we will look into a little bit into that, how this is done, right? These are still developers, but they just make their work easier. They still need the know-how of architecture, of integration, of all this kind of stuff. So developers are not going away. Low-code is just helping them to be more efficient. The second point is more about no-code. This is giving people who are not developers the ability to build software, right? And this is nothing new. If you think about Excel macros, Lotus nodes, whatever, we will see this. This is around for a long time. But this also can help that non-developers are able at least to build simple application workflows, dashboards on this kind of stuff. No, come on. Okay, here we go. So now let's look a little bit, actually, what is low-code? And here is a picture just of not all of them, obviously, but some of the players in this market. And this market, I just want to show, this market is really huge, right? New names, new startups are popping every day, getting funding. On the other side, all the big names, you know, like SAP, Oracle, Salesforce, etc., they're also in this field. They're also offering low-code. I try to order this picture just a little bit to give you some orientation. So there is, for example, one area here. This is the low-code for critical, serious apps in the industry. This is systems like OutSystems, but also Mendix, AWS is in this space. Microsoft heavily with the Power Apps. This is really serious apps, industrial scale, scalable for millions of users, web-based, mobile-based. That is just one corner. The big guys here, the big software vendors, they are offering low-code solutions to go from customizing to coding. So they know just customizing their systems is not enough anymore. Their customers want to distinguish, in particular in the front end for their clients, with their different software, with their different applications and apps. And their special processes, they need to code them. And so just customizing is not enough. So all these guys offering low-code solutions to make their customers able to code on their platforms, right? Then other companies going in the direction say, hey, let's address no code. Let's address people who have no skills at all in coding. They should be able to build applications and workflows here. Builder AI is an example of kind of a startup using heavily AI to do that. Then you have a big field in the area of workflows, business process optimization, or business process management. Also there, if you define processes, next step is to build an app to really run these processes, right? You see a lot of names here. Then you also find low-code, no-code in the area of data analytics, dashboarding, right? Something like Qlik, Tableau, you all know. ThinkWise is a startup just recently acquired by Databricks. So you see also in that space it's important. And of course, machine learning. We heard some talks how difficult it is to bring machine learning models into production. Also, this is tried to be made much easier with with kind of low-code solutions. Emerson SageMaker is an example, Data IQ, Data Robot, just a few names, right? But what is also interesting, there's also in the high-code area that you get better and better IDEs, that you get platforms like Flutter to make it easier to build mobile solutions, web solutions. So they're also going in this direction. And maybe at the end, they all meet in the middle, whatever that is. We will look at the last slides a little bit into the future. So this is all is converging at a point where coding should be as easy as possible. Sorry, wrong direction. Yeah, and this is just some numbers from analysts to show you how this is really taking up, and this is that there's really a demand. So, for example, there's a study from Tech Republic, a survey that almost 50% of companies are already using these tools. So the chance is high that also in your organization these tools are used, or at least are tried. Gartner even said that by 2025, about 70% of new applications will be developed by low-code. So that probably will also affect in some way your work. As I said, low-code is nothing new, not at all. The term maybe is new, and maybe the term is not perfect because people have problems with low and no-code. But you see a lot of different systems, approaches had been developed in history over the past to work in this. My favorite example always is Microsoft Excel. If you see what complex work applications, workflows, dashboards have been built with Excel by no coders, by people in the business, that's amazing. You see all these creative energy there outside of programmers, and just let's use this in a much better way than Excel, obviously. Yeah. So why is low-code stating that it makes development more efficient? What are the main pillars or the most important things here? And I would say these are three things, and we will look into each of them. This is standardize as most as possible, almost everything, right? Make it already available so that you don't have to reinvent the wheel, do it again with each program. Abstraction, we heard this in other talks here on GOTO, is languages, programming frameworks is going higher and higher in the level of abstraction. And an interesting point, I think, is visual programming. So why writing code in a language? Why not using visual tools? So let's look into these three things. Standardization, of course, I mean, you know that's everywhere. Predefined things, you can standardize like the whole infrastructure basis, database, OS, this kind of stuff, right? Software development life cycle, that all should be standardized. A software developer should not cope with this for every app. Again, this should be just given. Again, the same thing, integration with other systems, interfaces. So low-code tools bringing this to the table, defining this, having this ready to run out of the box. If you want to do it differently, you always have the possibility to write your own code and connect it via these interfaces, obviously. But usually, for the apps you are building in your enterprise context, that should be enough. And a simple example I have here, if you create a database table in a low-code environment, these CRUD routines, you know, for create, read, update, delete, are already created for you. They are available in a graphical way. You see here a screenshot here easily, so you don't have to cope with this, just as an example. Another example would be plenty of UI templates, predefined, maybe along your corporate identity, so that you define this as templates, and this is all available in the tool. Another thing is bringing abstraction higher and higher, and that is something which there's a long history in computer science, computer engineering about this. If you just look at the journey from assembler to computer languages to domain specific languages, so there's more and more abstraction, and low-code is the same thing. Here, what I show you here as a screenshot is a development environment. And it looks very similar to other IDEs you probably know. You have a canvas in the middle. The interesting thing is that this is not a programming language here anymore. You define the logic, the flow in a graphical way. You have a toolbox, and with a mouse, drag and drop, you move the tools you need onto this canvas. You can specify the properties of each object in a property editor. And at the end, you have one button, the click click the click publish button, you click it, and then the code is generated, it says deployed on the server, and you get the URL, and the app is ready to run, right? And the idea behind all of this is specify what you want to do and not just how to do it, right? And this is a general schema in computer science. If you look at things like Python, Pandas, Spark, for example, you specify what you want to do and no longer how to do this. Let the computer or the compiler figure that out for you. Yeah, another interesting thing I think is low code is very much going into the area of visual programming. And if you listen to the talk this morning, to the keynote from Alan Kay, he was talking a lot about visualization, right? Already in the 60s and 70s. And the question is why to specify code anyway in a language, right? Alan, I think this morning called this a virtual punch card because that's where it's coming from. It's coming from the von Neumann computers where you have the actions the computer is doing, and you specify exactly every step, right, as an action, and you write this down or you put it in punch cards, and then now you're writing these commands in a list, and that's basically what an artificial computer language is. But you know, we talk in software engineering also about architecture, and we compare ourselves to architectures of bridges, of cities, and these architectures would never describe their things with a language. You would not describe a bridge, to build a bridge in an artificial language. You do it in a graphical or visual way. You draw construction sketches and plans, right? And maybe that's also something we should do in software engineering and programming, right? So, and as you see here, there's a long list, a long history of doing this. UML is a great example, still around and people using this, right? And in low code, here's some examples on the screen. For example, the logical flow you easily describe visually. Also the database model, right? You see the different tables, the keys, the relationship between the tables. That's something you can easily do in a visual and graphical way. But now you would say, hey, we have a lot of engineering developed over the last years, right? For really modern and efficient software development lifecycle. Something like microservices, test-driven development, continuous delivery, all things discussed here on the conference. And yes, this is also available for low code. Maybe not for all the different systems you have seen on the screen, but the main ones, at least the ones for the bigger critical industry applications, they also have these practices available. Let me show you. So this is an example of how to build microservices. You know what microservices are. Instead of a monolithic architecture in layers, you have an architecture of independent services. They are loosely coupled instead of closely coupled, right? In low code, this is here an example how you can do this quite easily. If you write one of these services, then you can decide either you expose this functionality as a server action, and then this is closely coupled, right? It's running on the same server in the same environment. Or you can click, hey, this is a service action, not a server action, a service action. You see this here. You can say a server action or a service action here. And if you click on service actions, then it is coupled via a REST API or SOAP API, right? Loosely coupled. So just with one click here or there, you can decide to run this in a microservice manner or in a more monolithic architecture, right? Sorry. The same thing is true you can do easily in these environments for test-driven development. You know test-driven development, you first write your tests, you don't have the functionality yet, you just have a wrapper or framework, the tests are read, obviously, you don't have the functionality, then you program your functionality until all the tests are green. In low code, if you want to build a module here with some functionality, for example, imagine you build something to calculate some payment, so payment calculation functionality. You see here some description of the formulas, some tables, how to do this. So you build this as a module. The module has APIs where this functionality is provided to other modules that can use it. And before you start coding, you write another module, and this is the testing module or the testing app. And here in this testing app, you define your test cases for this functionality, and you call these APIs to test this functionality, right? And in the beginning, this module is empty, and all the tests are red, obviously. Then you program your functionality, your payment functionality, and then whenever you commit or transport, you automatically run this test, this module, trigger these APIs, run the tests, and you do this until, the same as TD, test-driven development, you do this until all your tests are green, right? And this can be done automatically. It can be combined with pipelines, with commit statements, deployment, whatever it's needed in your environment. And not only the tests of this module, tests of the other modules as well. So you see if you accidentally have broken something when you created a new model or another functionality. So that's the principle of test-driven development, and it can also, of course, be done in low-code environments. Sorry, wrong direction. The same is true for modern continuous delivery, right? Where you have pipelines, you have different environments where you develop, where you run regression tests, acceptance tests, where you go to deploy, maybe pre-deployment. And in low-code, again, you have your different environments, you have pipelines between these environments, and you have tools who control these pipelines and control the whole workflow. And usually these low-code platforms bring these environments with them, but also they usually have APIs, so you also can connect other well-known orchestrators, for example, Jenkins as one example, and others, or Microsoft cloud-based orchestrators. You can use this to control the whole workflows in this pipeline system to build your continuous delivery, continuous integration pipeline. So that's very similar to classical or high coding, right? Yeah, but now when you consider this, maybe using for your work and your organizations, what should you consider before jumping into this? Just a few tips here. An important question is, are low-code developers available? At the moment, there's very high demand because there's a lot of hype, a lot of people jumping into it, trying this out, and it's not so obvious that you have these developers. Maybe you want to learn it yourself. If you're a developer, it's quite easy. There are some good trainings available publicly. It probably takes you a couple of weeks to dive into this. You have demo systems, your own environment, so you can really play with this and work with it. So probably it's kind of easy to learn for you. If you don't want to do this, you hire external people, but check. Nowadays, getting a low-code developer is maybe even more expensive, and they have higher rates than Java developers, because there's so much demand on the market at the moment, right? Then you have to decide for the low-code platform. And you see there is a huge variety of systems and vendors out there. And really, if you check them, you should check also not only what they are able to do now, but also the long term. Because if you're building critical applications for your organization, they are usually, or they're there to stay for years, or maybe tens of years, decades, right? So maybe they have a great APIs now, but are they able to maintain this over the years? Yeah, APIs are changing all the time, right? You have to update them, maintain them, document them. So is the vendor able to do this over the future? You should check this, otherwise you might run into problems in the future. Another question is, if at one point in time you want to get rid of this vendor, I mean, you have running these apps, what do you do? Some of these vendors, this is kind of a black box, and if you take the platform away, the code is not working any longer. So you don't have the app. There are other vendors who are generating code like C#, .NET, JavaScript, CSS for the front ends, and you get this code, and you even can continue to run this code on your servers if you're no longer subscribed to the low-code vendor. But don't believe that it's easy to maintain this code and further develop it. It's generated by machines. It's hard to read. It's very hard to maintain, right? But at least you would be able to run the application a bit further. So that's what we call vendor lock-in, right? And another thing, a lot of people don't think about this. Imagine you write a little app for your organization. It works really nice. People like it. More users are coming. You're scaling up. Business coming with more requests, more features. And the app is growing bigger and bigger, and it's getting more and more important for your organization. Maybe it's mission critical even, right? And then it has to scale to from 10 to 100 to thousands of users, maybe even external users. So is the vendor able to do this, right? Is it scalable? And it's not only scaling, it's security, it's integration, all these things, right? And if at some point you say, hey, I don't want to run it any longer on low code, it's so critical now, what do you have to do? Do you have to replace it? Has this become the next legacy system in your organization, right? And you have to rewrite it again? So that are questions you should think about this. And one thing also to be careful about is the last point. I mean, I showed you these tools of software development lifecycle. They are nice, but they are not scaling as well as traditional coding, high coding, as all the tools you know out there like Jenkins and Circle CI and all this stuff. I mean, they are working, but the bigger the team, the more complex the application, the more problem you run into. They are centralized. They have a central database, for example. You run into bottlenecks. And if you have teams bigger than, would say, 20, 30, 50 people, or even going 100 people, working in one low-code environment, you run into trouble. It's not really scaling very well, at least not yet, right? So it's more for smaller teams, single people, development staff, it's great. But for big teams building complex software, I would be very careful using this, right? Just as one device. If you're even going so far in your organization, say, let's build up no code. Let's provide some tools so that our business people can develop their own apps, which is great. But you need also a lot of governance and organizations around this. You don't forget this. What you do here is you build up a shadow IT. Usually people in IT don't like this because people somewhere else just doing IT without any control. And you have to define rail guards around it, guidelines to manage this, right? So who is able to do this? What about the users? What about security, authorization? Who's organizing this, right? How to onboard business users to use these tools? How to give support? You need a support organization for this. They will have questions. They need data in your organization. Maybe they want access to your SAP system or CRM system, right? To build some of the apps or dashboards. How do you do this? You provide APIs. You have to maintain them. You have to check authorization, security, who is able to read this data. Millions of things you have to think of, so it's not easy. It can work. I know organizations who really very successfully built that. People in the organization love to build their own tools, much better than Microsoft Excel, but it's a lot of effort also by the IT department and by the developers to set that up rightly. So at the end, let's look a little bit into the future of low-code, right? So where is all this going? And one thing is, you see this in all this tool, and you have seen this on the picture already, is you are trying to use AI, machine learning. That's a big topic in this area. And kind of an easy thing everybody is doing, and this is live already, developing this kind of AI assistance. That is kind of a suggestion, recommender, right? And because these, usually your low-code applications running in the cloud, the vendor has access to all this code of his clients, it's easy for them to train machine learning, AI algorithms on what people are doing, and based on this training, on all these code snippets they have, they can do suggestions. Just see this here in this line. You always click suggest me, right mouse button, suggest me, and even by this you can already click a running application. It's a bit like, you know, WhatsApp, you have these suggestions, you just click next work, and you come up with some message. Maybe it doesn't make sense, but it's a correct message, and that's the same here. And for standard work, this works pretty well. There's already a suggestion by the system helping you. Also, in terms of when you run into an error, the system knows pretty well what you probably have done wrong and points you to the right thing and gives a correction how to correct this. And this is at least syntactically correct. If this is really what you want to do, you obviously have to check. But this also makes programming for not that experienced developers much easier. But oops, I'm sorry. There's more on the horizon. And one thing I think is particularly interesting is you probably heard about these large language models developing in the AI machine learning space. OpenAI, GPT is an example here. DeepMind is doing this, Google. And they are not only using this for text and natural language processing, like translation and chatbots and this kind of stuff. They are also using this for code, because code is also is a language, right? It's an artificial language. It's even an easier language syntactically than the natural language. And I want to show you 2 examples at the end. One is from Microsoft, and you might have heard about it. It's the GitHub Copilot. Yeah, there was a lot of buzz on the market. It is already in a technical preview. It's available. You can register for a user. It seems to be pretty easy. I got one in a couple of days. I just tried it out before coming here to GOTO. It works amazingly well, so it's really interesting. So they have trained their large language model of millions of lines of code on the public GitHub repository and other repositories. Works for a lot of different programming languages, and it's kind of an intelligent autocomplete. I mean, this is maybe an underrating, but here you see, just make your own picture. 2 examples. On the left side here, the user wants to write a function to determine the sentiment of a text, right? So that's what he's writing, determine whether the sentiment is positive. Use a web service, and then he starts with the head of the function, is positive, input string, and then a promise is a Boolean. And what you see here, the blue box here, this is immediately created by the Copilot. So he knows about this web service, he knows a web service for this, and he just writes the function to call this function here, the web service, get the response. The response is in a JSON format. He gets that out of JSON, positive, and returns this label, right? So that is something automatically generated, and it really doesn't take even seconds. It's very fast. So you should really try this. It's very interesting. Another example, I think it's really nice here. This is about writing test cases. And you know how hard and cumbersome and time-consuming it is to write all the test cases. And here you have a very simple function, strips suffix from a file name. He's saying removes the suffix from a file name. This is the return here, so very easy function. And then you write define test strip suffix, so test this function. And Copilot immediately sees, okay, let's define some test cases. Assert, for example, notes.txt. Assert the suffix from node.txt.js. Just a few examples, right? So this was done automatically, and that is pretty amazing. Another second example I want to show you, and this is much more research. It's not public available yet. That is really the state of the research. It's from DeepMind in London. They call this alpha code. It was published, I think, in April this year, so pretty recent. And again, it's a big, large language model, like the OpenAI model. And this time it's again trained on GitHub and coding, here in this case on Python and C++. And it is trained on exercises, coding exercises. And there is a public coding exercise platform out there. It's called Codeforce, pretty well known and popular. And they trained it on the descriptions of the tasks, of the exercises, and then the actual code, right? They trained this. And if you see the outcome here, this is one example. This is a description of the coding example, and there's some basic input here. You can read this offline after the talk. The idea is you have four examples. You have a longer string, and you have to produce. You have to check if you can produce a shorter string out of this just by either clicking on these letters here on your keyboard or clicking the backspace. That's what you're allowed to do. Nothing else. Just the letters in this order or the backspace. And are you able to generate this string out of this string? That is the question. And you see for the first example, the answer is yes, because you would hit backstring, 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 and then B and A, and then you have the output B and A. For the second example, it's not possible. You could hit backstep, then B, then you don't want to have the A, you click. If you would click a backspace again, you would delete the B, right? And then the B, you would end up with AB. So it's not possible to generate the BB, and you see the correct answer is no. And this is the code Alpha Code has created. So that's pretty amazing, right? It's a Python code, and I haven't tried it in my compiler, but it seems to be correct. So the AI is able, from this natural description of this not so easy exercise, tricky exercise, to generate this code. And as we have seen in the previous slide, they are able to achieve a rank of all the people in this competition of about 50%. So they are not superhuman yet, so far away from this, right? But they are kind of comparable with human programmers already, right? I mean, this is more research, and I don't want to put the expectations too high. You really also have to be careful. This is not ready yet for replacing you as a developer or for prime time even. Yeah? So, for example, Microsoft claims that for the Copilot, they only get it right in about 40%, right? So that is not perfect. So more than half of the time they get it wrong. And if you let them try 10 times, this increases a little bit to maybe 60%. But still, in 40% of the cases, they never get the right answer, right? And what they are creating, this is not even compiled. It's not even sure that it is compiling correctly. It's just generated text, that's all. Yeah? Maybe it doesn't compile correctly. Maybe it doesn't make no sense. Maybe it's the wrong answer. So you really have to be careful with this. And one of the reasons is the context to generate these recommendations, these suggestions, is on a context which is quite small. It's maybe a couple of hundred of lines. And you know, coding can be much larger. Source files can have thousands, even much more lines of code. You can have a lot of different files. So the program doesn't know the whole context, and therefore he cannot always make the right suggestions. And maybe they are recommending depreciated libraries. Maybe they recommend things which is not secure, right? They even can recommend some personal information, because this personal information have been in the training set, right? You don't filter these millions of code by all of this. So it could be that there even are email addresses, codes, keys, whatsoever. So really you have to be careful. As a summary, last slide from my side. I hope you got some sense what low-code is, how low-code can help you in your daily work, in your job, and it's hopefully, you see, it's not a threat to you. It's a toolbox. It can make you more efficient. There are a lot of tasks there where this really can make you more efficient, can help you or other people, right? Certainly not for everything, and still software skills, architecture skills, software engineering skills are still in high demand. This is not going to change. It can really boost the efficiency. It's great for rapid prototyping. It's great for agile. It makes agile processes even more agile and more faster. A sprint is maybe no longer a week. It's maybe just days. It's great to cooperate with the business. Business usually is amazed if they say, I have an idea. And you say, okay, let me do this. Is it like this? And say, wow, no, I want to have this like this. And this is a very iterative process then. And that's sometimes mind-blowing for people in the business, right, if you do this together. What is also nice, usually you develop it once. It runs on all the different platforms. The last point is just to give you some food for thought for going home this afternoon. It's going in the direction of democratizing development, right? And just think about this, what this means. If at some point in time everybody is able to code, to write program, right? It would be a completely different world. It's like today, everybody is able to publish something on the internet or is generating music with easy tools. And this publishing has completely changed our history, has made open source available, has made Wikipedia, this stuff possible, right? And what would happen if everybody is able to write code, right? That would be a completely different world, maybe a great world, I don't know. But low-code maybe is one step into that direction. And with this, I'm done. Last slide here. I hope that's maybe the movie Casablanca, and I hope you get this idea that maybe developer and low-code just is the beginning of a beautiful friendship. Thank you very much.